Hello everyone and welcome back to Watch Jala Code. This is my devlog and today we'll be talking about Cliano, a Rust-based piano I made. I made that yesterday and I posted a demo video. So go check out the demo if you want to know what this is about. I was just tired of web development because I'm a web developer, at least a backend web developer. I'm tired of all the JavaScript, tired of all the NPM. I was tired of everything. So I just decided to do something else. And I'm also familiar with Rust, but I hadn't used Rust for like 2 months. So I thought of doing something that would help me re-familiarize myself with Rust and would also be a nice project. Thus, Cliano. So Cliano is like just me messing around with Rust basically. And I'm just gonna take you through how I built the whole thing. Now, before we jump right into the code, I would encourage you to give the video a like and subscribe for more. Also, comment down below what you want to see me build next, and also tell me what language you want me to use. All right. So initially, I wanted to build a CLI tool, and I thought that I would need some nice CLI crate. And my go-to crate for this was clap. And that's why we have the configure CLI function right here. However, the function only contains like 4 lines and I ended up just using clap for metadata. I thought when I was building, I didn't really know what I was doing. So I thought I would pass maybe some arguments or whatever. But as I began to write the code, I didn't see any reason to pass in arguments. This is just like an application that works in the CLI. In fact, at the end of the day, I think there was no real need for clap, except maybe to check how it works via like help or something. Okay, so after figuring out what I would use for the CLI tooling, my next concern was for audio data. I had no thoughts of synthesizing the piano sounds on my own. So I pulled up ChatGPT, and after some back and forth, I settled on using the University of Iowa's Electronic Music Studio as my source. They've actually got great stuff and I would definitely recommend. So I got some files, maybe like 13 of them, and then I converted them to WAV. That's the .wav format, because that's what the audio library we used, Rodio, actually works with. And Rodio is conceptually simple. So the first step with Rodio is setting an output device. And for that, we use output stream try defaults. And it could fail, so I used the .accept method. I didn't do any proper error handling for 2 reasons. First one is that I'm not really good at error handling in Rust, and I've actually forgotten how to do the basics that I learned with error propagation. And the second one is, first here, if we don't have speakers, then the piano is useless, so we can just crash the application. So anyway, if we successfully do get speakers, output stream try defaults returns 2 things: the output stream and an handle to the stream. So the first thing it returns, which is the output stream, we don't really use that for anything. But the handle to the stream, however, we do use that. And that's what we use to communicate to the output devices what sounds they should output. So we don't lose sight of these 2 things. I created a piano struct and saved them there. Along with the output stream and output stream handle, the piano holds a sync, that's the struct. It holds a sync, a state variable called is playing, and an optional hash map that holds character and array pairs. The audio sync is something we can get from Rodio and helps us to smoothly control audio playback. Of course, we had to instantiate our piano struct, so I implemented an associate function called new. This is like constructors in like maybe JavaScript or whatever. So new instantiates everything in the piano struct but the note key map property, which I set to none. This is what's supposed to hold our optional hash map, so I set that one to none. And after all this, I realized we would need an application loop, because this is like kind of like it's an actual app. You don't want to just press one key and run out. So I implemented a run function on the piano structs. This is the place we also handle inputs using the crossterm crate. Yeah, Crossterm was the third library we used here. We call something called the draw keyboard function. I won't tell you much about the draw keyboard function because this is something I asked ChatGPT to make. It used crossterm, and I don't feel like explaining it because it's not my code. Yeah, that was the only part I used ChatGPT, so the rest was myself. So after calling the draw keyboard function, it's what prints out that nice function we see in the CLI. Then we immediately enter an infinite loop. Yeah. After that, we call a function called poll, or P-O-L-L. I don't know how to pronounce that. Anyway, we enter this function, and it's a function from the event module of crossterm. It checks for terminal events, and you can pass it a duration for how long it should check. So it can check for events like writing on our terminal or whatever. So if we find nothing after waiting for 100 milliseconds, we just move on. That's how I wrote the code. And I personally don't think all is necessary, because right after using poll, we call another function from the event module called read. And read is actually what gets us the event, what reads the event. Poll just checks if there is an event in the event queue. Read actually reads the event. But the difference is that it blocks the thread. The read function blocks the thread if no event. It waits on an event, which is blocking. So using poll guarantees that, okay, something is present, so we can just pull it out immediately with read, therefore not blocking the thread. I tried it with and without poll, and I actually feel like there's no difference. But if you do feel like there's a difference, please treat me in the comment section. And while you're at it, leave a like and subscribe. So moving on, after we read the event queue and get the current event, I specifically checked if the kind of event is a key press event. That's because I think we've got two types of key events. At least I noticed two types. One was key press and key release. Initially, when I just had a print function in this block, it would print out 2 characters. So I didn't know why. Initially, I actually thought it was because I was running the application in debug mode, because I believe React has something like that when you are in strict mode, where it logs the first thing twice. So I thought that was the problem. So I shifted to release mode on cargo, but it also didn't resolve my issue. So then I did some research. I found out that, oh, we actually have 2 events, key press and key release. I'm only listening for the key press function. So when you hit the key, that's the event we consider. So after that, we match the event code. If it matches a key code character, we call the handle keys function. Handle keys is what actually plays the sound, but we'll get to that later. And if it matches the escape key, we break out of the application loop, which exits the application smoothly. So that way you don't have to do something like Ctrl+C, because I didn't handle Ctrl+C, I handled escape. If you use Ctrl+C, you would actually just kill the process prematurely. But if you use escape, you just exit the application loop quite naturally. Okay, but even when we've handled the character, before we can get any sound, we need to load them up. So that's why I made the load keys function. Okay, so the load keys function was actually the hardest part of the code, but now it's actually quite simple. The function takes a static string that points to the directory where we keep the sound files. And when we're in the function, the first thing I did was to instantiate a hash map of character and vectors. The vectors hold the actual sounds. This is how I store the sounds in memory. So let's keep going. So after this, I call a function file to key map, which passes back another hash map. The hash map holds pairings of the names of our audio files to keyboard characters. It helps us to know what keyboard character maps to what sound. For example, if I click A on my keyboard, what sound does it map to? Is it C4, D4, or whatever? After this, I iterated through the keyboard sound directory. I got each file's path, then got their file names. And in this block, we get the key that each file name is mapped to. Open each file using that path, create a buffer, and read the content of the file to that buffer. Then we insert each key and buffer pairs into the sound hash map we made earlier. I did this because I didn't want to read the associated sound file each time a key was pressed. That's why I actually decided to store them in memory, because imagine if we clicked a key on the keyboard, then we did some stuff and read from the sounds file, the sounds path on disk. Means we would have to do IO anytime we tap a key. That, I felt like that would be very bad, so I didn't do it. That's why the load key function helps us save all the sounds to memory at once, which is only like 54 MB of memory, so it's not too bad. Okay, but the problem now is that the Rodio's playback sync only reads from streams. When we open the file, it was a stream, but now it's just stagnant data in memory. This was actually the difficult part of the code. I originally didn't even write it like this. I tried to save the stream in some arc, and that ended very badly. The code didn't work and looked so terrible. Then I did some Googling and found something called cursor. I'm not talking about the cursor application, but a cursor is something that wraps an in-memory buffer and provides it with a seek implementation. Now, our in-memory buffer can be reused. We actually play in the handle keys function. So maybe I should have called it play keys. Anyway, in the handle keys function, we first redraw the keyboard and tell it the key to highlight. That's why whenever we click it, we see the blue glow. When we click a key, we just see the blue glow of the key in the terminal. After that, we get the reference to the in-memory node key map that holds our hash map of key sound source pairs. Then we get the source associated with the current key and make a new cursor. Yes, the new associate function for the cursor type requires an own buffer. So I just cloned the memory source and passed it to the cursor. Then I passed the cursor to a buff reader. Then I passed the buff reader to the Rodio decoder. And I took the first 5 seconds of the sound. Now we have a source and we can actually play some sound using the source. Before I played the new source though, I checked if a source was playing. If it was, I stopped the playback and set our is playing state variable to false. At this point, I asked myself a couple questions. There were like 2 ways I could have done this. One was to append a source to the audio sync. This adds it to the queue of what the sync is going to play. Then I would call a function called skip1, which would skip ahead, so the one we just added to the sync. But I felt like over time, as we kept pressing keys, we would be growing our application memory usage with every key we played, because we would keep adding them to the queue. And I didn't know how Rodio handles things in queue if it didn't touch, like things it had skipped. Does the application dispose of them or what? I actually didn't know. I didn't want to find out in prod, so I tried it out. And to my surprise, which actually makes sense because I guess the Rodio guys aren't incompetent, there was no change to the memory usage of the application even after playing a whole song. Meaning, even if I just kept adding stuff to the to the audio sync queue and skipping over to that, there would be no change in the memory regardless. I think it would dispose of the ones before. Maybe that's why the sync doesn't let you go back and forth. You can only go forward. Meaning what was previously in the sync gets discarded. Maybe that's why we only have skip 1 in the forward direction and doesn't take us back. So, but even though, regardless, I chose the second option of stopping the playback and appending a new source, then setting our display variable to true, because I just felt like I guess it would be better to do this. And that basically brings us to the end of the code, and we've got a functional piano. Isn't programming just awesome? This is actually a fun project. Starting from basically nothing, we turned our laptop into a minimal piano. And times like this is just why I learned how to code. Like, you can basically do whatever you want when you get to a certain level of programming expertise. Anyway, if you made it this far, thanks for watching. Go explore the code. I left the link in the video description. Give a like, comment, and subscribe. Also, what do you think I should build next? And what language do you think I should build it with? Maybe Go or TypeScript or something.